using something called triangulation. It might sound complicated, but we'll explain it in a super easy way. Let's get into it.
In this video, we will be showing you how and what triangulation method looks like. We will be needing compass and a map. Okay, so let's say there's an earthquake. Scientists want to find out exactly where it started, which is called the epicenter. They use a method called triangulation to figure this out.
Imagine we have three seismographic stations which are like super sensitive to record the earthquake waves. We'll call them Station A, Station B, and Station C. Each one picks up the earthquake waves and notes when they arrive.
Each station then figures out how far away the epicenter is by looking at how long it took for the waves to reach them. They draw a circle around each station where the radius of the circle represents the distance from the station to the epicenter.
The cool part is that when you draw this circle, they overlap at one point. That point where the whole circle intersect is where the epicenter of earthquake is located.
Sometimes the circles might not overlap perfectly due to errors or differences in data. But with accurate measurements, scientists can still get a pretty good idea of where the earthquake started.
Now, in calculating triangulation method, let's have triangulation method sample 1. And as you can see, the time difference in each recording station is already given. Primary waves and secondary waves. To get the lag time, we will subtract primary wave and secondary wave. We will be using a formula which is D is equal to TD over 8 seconds times 100 km. Firstly, let's solve Batangas. D is equal to TD over 8 seconds times 100 km. T is equal to 26 divided by 8 is equal to 325 times 100 km, and it's equal to 325 km. To get the centimeter, 325 divided by 100 is equal to 3.25 centimeter. Now let's move to Palawan. First, let's write the formula. TD over 8 seconds times 100 km. T is equal to 50 seconds over 8 seconds divide 8 divided by 50 is equal to 6.25. Then times it to 100 km, it will give you 625. To get the centimeter, repeat the procedure that we did in Batangas. Divide 625 to 100, it will give you 6.25 centimeter. And lastly, let's move on to Cagayan de Oro. First, let's write the formula. D is equal to 4 over 8. Divide 4 to 8. It will give you 0.5 times 100 kilometers. Times them, and it will give you 50 kilometer. To get the centimeter, 50 divided by 100, it will give you 0.5 centimeter. Now that we solve all the recording station, here's the update of the triangulation method. So here's a quick rundown. Record waves. Each station records the time the earthquake arrives. Calculate distance. They figure it out how far the epicenter is based on those arrival times. Draw circles. Each station draws a circle around itself with a radius that shows how far away the epicenter is. And lastly, find the spot. The epicenter is where all those circles meet.
Finding the epicenter is important because it helps us respond faster, helps emergency teams know where to go for rescue efforts, improves safety, helps in planning better construction and safety measures, understands earthquakes, gives scientists more info about how and where the earthquakes happen.
So that's how triangulation helps us find the epicenter of an earthquake. By using data from multiple stations and drawing circles, scientists can pinpoint where the earthquake began.